start with a recap, right? Maybe by the time people will join, um, I'll share my screen. Okay, so uh, can everyone see my screen?
Yes, Sumit.
Okay. Uh, what we did was in the earlier session, we started with the new syntax sessions. Again, new syntax is something that is generally categorized for any new variation that has come up post ABAP 7.4 version. And one of the most common version, common variation is something called as inline data declaration. So in inline data declaration, we saw what is data and field symbol declarations. For data declarations, there is something called as loop at internal table, read table, find, when you do method calls, etc. In this, what happens is that you don't have to create a data type and create a data declaration for a work area separately. You can directly do it inline. That's the reason it is called inline data declaration. That is one type. Then we saw one example in the slides where the red area, which is there, this particular area plus the black area is combined. Uh, like this is the data declaration, this is the data assignment. Both of them are combined using the inline data declaration. Thereby, we can save a lot of time in terms of writing our code. The same thing can be used in the select queries. As we discussed, select query is something that we'll take up in the subsequent sessions that we have. After that, we also understood that similarly, we can also have things for field symbol. So in field symbols, what happens is there are two steps. One is the declaration and second is the assignment. Again, so both of them can be combined together in one single line called as field symbol uh, keyword and the field symbol name. Okay. Then we went to something called as constructor expressions. So in the constructor expressions, there are primarily four expressions which are kind of main expressions that we use most commonly. The first one is the most important in my opinion, called as value expressions. Okay. So in value, what happens is that let me also take an Excel. So see, in an expression, there's always a LHS, then an equal sign, then an RHS. Okay. So in the LHS, what happens is we have something called as target variable. On the right hand side, we have the constructor name. Then we have the structure. Then we have the values, right? That's how we basically construct it. Okay, so these are the components of a expression always. So always try to kind of see that this is how a expression happens. So let's say you have the value expression. Okay, so in a value expression, you will have data lt itab. Okay, this is what it is. This is the LHS. Then you have the equal sign. When you come to the right hand side, you have value, which is the keyword. Then for some instance, there is some table type that we have created. Okay, table type, let's say VBAK, something. Then what happens is when you come to this syntax, you see that data is done, itype is done, value keyword is written, the structure name is given. Then you have the general open and close. Okay, so this is there. This is the open and this is the close. Okay, and you have a full stop. So this is, you have created the skeleton. Now, based on your requirement, how many rows that you want to add, you can just add one by one. You can have column 1 is equal to 1, or then column 2 is equal to 2, column 3 is equal to 3. This is your one row. Okay, so each row will also have this open bracket and close bracket, and depending upon the number of columns that you have, you can give the particular data. Okay, so this is how basically you need to understand that there is an LHS and an RHS, and the left hand side you have the target variable, and on right hand side you have certain syntaxes that you have to follow. For example, you have the keyword, then the constructor name that is there, which is value, then the structure that you have created or which is there in SE11 that you're going to use, and then obviously the values. So the value will have the overall opening and closing brackets, and for each row there will be an opening and closing bracket, right? So for a value statement, maybe let's go to the code. So this is how the value statement usually happens, right? So you have the inline data declaration for the target variable. Then you have the value statement, the structure. So this structure was created within the program. Okay. This is the structure that was created, and this was the table type. So this table type has been used here. Then you have the open bracket and for the overall value statement, and then the open and close bracket for each row. So for formatting purpose, it's better that you can create this like this, so that you understand it quickly. Where are the opening and closing brackets? Okay. So value statement, what it does is it adds the data row by row for the target variable. Okay. So the same thing, if we go up for the table expression, that will come. Sorry, we'll go down, and when the table expression comes, we'll also understand its usage. Now the second one is CONV. If we go to CONV, this is a very simple operator, is used as the name suggests, for data type conversions, which will help you in terms of if at all you have a data that you want to convert its type for your use. Yes, this hash thing you have asked, I'll cover in one of the further expressions. So again, it's a very simple thing. For example, if 1 by 3 is greater than 0, we will never be able to go inside, because this is integer by integer, which is 0. But if at all we want to make sure that we kind of also use the float version, or the float part of the result, we basically use CONV. Then we use decimal float, which is the data type, and then we can just add the result in the brackets. Okay, so that's how we kind of do it. Now when we come to the third one, is called as COND operator. COND operator is mostly a substitute for if-else statements. So in this, what I have done is, first statement I have created using the normal comparison, like with site time low is less than 12. In the second statement, I have also further used one more constructor expression with CONV. This is just to make sure that if site time low is not in the required format, so what I can do is I can convert this particular result into the time format using CONV as well. Like I told, you can also use it like this. But if you think that there is a variable that you might see that it is not in the desired way, you can use CONV. Okay. Uh, Now, in terms of the format that I told, in the constructor expression, this particular thing, right? So this particular thing, you have to specify the structure name. Okay, always. So when you see it, you have your string is written here. Then you have written decimal float, basically the data type or the structure, right? Then you have written TT underscore data. So you have telling the system that what needs to be the target variable's data type. Okay. Now, when you specify string, you can either specify string as a word, or you can specify hash as a symbol as well. Okay. So by default, what SAP does is it actually tries to understand what is the target variable's uh, data type using the statement which is there here. Okay. Which is here. Now, for some reason, if it is not able to decipher that, it will make sure that it is taking string as the default variable. Okay. So 99% it will work if you just put it as hash and then it will take the string. So for example, here also, if you know for some reason I know that it is string, I can just put as hash. So like here I have put as hash. Okay. So the hash is something that is not always mandatory. You can always give the data type. But then if for some reason you know that it is always going to be string and something, just keep it as hash. So in standard programs or programs that have been created with someone, they would have put it as hash. So this is useful to recognize that. So in the switch statement, the switch statement is used as a substitute for case and case statement. Okay. So when I go to the first, so this is the conditional statement that we saw. So the next one is case statement. So case statement also similar, where we have the left hand side, which is the inline data declaration. Then we have something called as the keyword switch, then string. In a keyword for switch, see, like we have a comparison variable. We have the comparison variable sci index. We have when statement in the earlier syntax. We also have a when, but here we also have something called as then statement. So then statement is used so that whatever is written after then is transferred to our target variable, which is number. Okay. So that is how you use the switch operator. Now in table expressions, as we saw, there's something, the main statements are read statement, this one and this one. The first one is used for index. The second one is used for column comparison. And the likewise substitutes are that you can have a square bracket with index number or a square bracket with column names. Okay. So when you do that, again, I have given you some variations in this where you can put it in a try catch. The reason I've told is because if at all there is no row that is found for that particular table, then for that index, it will give you a short dump. So this is how you kind of handle that short dump. Okay. Similarly, there's something called as value. Okay. So value is something that if at all if at all this particular index is not available, or that matter this field comparison is not available, so you can give a default statement according to your logic. Again, this is something based on your use case. Okay, it doesn't mean that always you have to give a default. You can always do a try catch and leave it, right, like this. Okay. Then we also saw something called as chain command, where if at all you don't want the entire work area, but you only want the field associated with it. So like how you access a field of a structure, you can do a hyphen and then take the field. Okay. So this was one of the most common thing for our internal table operations. We saw the variations of try catch, default, chain, and also as well as the structure. Okay, then there were around three common methods that were used. One was line exist. So line exist is a very as the name suggests, it will just tell you if the particular row exists in the item. So if the internal table has that row, it will give you a true value associated with it, so that you can do some condition based logic. Okay. Similarly, so it's like read table transporting no fields and a size of RC equal to 0. That means that is having a row associated with it. Then there is something called as lines. This is the method. It is a substitute for describe tables. I tap the lines, right? You can directly use this syntax. Line index, as the name suggests, it is used for returning the row number or the index number for the condition that you have mentioned. For example, field 2 is equal to 2000. For our table, field 2 is equal to 2000 is here. So it will give you the third row, right? So here in this row number, you will have the value 3. Okay. So those were the common things that we saw in internal table operations. Then, we saw something called as chaining. We also understood that, in the current syntax or the syntax before 7.4, you can do that, you can only do structure to structure move corresponding. So if at all you wanted to move the data of an internal table, you needed to do a loop. And then after that, you had to do a move corresponding structure 1 to structure 2. But in this current syntax, you can do move corresponding for the entire table. Okay. Then we went to something called as character or string processing. Okay. So in character and string processing, we first saw what is pipe operator. Okay. So for the benefit, I'll just repeat it again. What is pipe operator? So when we see old syntax, right? In old syntax, or some when I refer old syntax, that means the syntax that we use in 7.4 below versions, right? You have single quotes to make sure that you create certain string data, right? Test is there. And when you want to do a concatenation, you use the concatenate keyword, then the string or the variables into a target variable, and then you have either a separator. Okay, that's how we kind of use it. Now in the new syntax, you can replace this inverted commas using something called as pipe operator. Okay, so pipe operator is similar to what is there for open quotes and end quotes. If at all there is any gap between the pipe and the variable and the text, that is also considered as a text. So it will be, if at all there is gap, that means it is considered as space. Okay, so the one advantage, like I told in the last session, is that the particular variable can also be given in the pipe operator, so that you can have the value of the variable. How do we do that? For example, this is the variable sub rc1 new. You can use it in the pipe operator with a curly bracket. You open the curly bracket, you add sub rc1 equal to new, close the curly bracket, and then obviously you close the pipe operator. So instead of writing at size sub rc, you will get the value of the size sub rc, okay, which will be written. So that's how you kind of use pipe operator. Now one more a bit more complex is this, line number 540. So for example, I want to write the system language. So I open the pipe operator, I hard code the text system language, then I create a variable bracket for system language. I close it. I give a gap, again system time. I give the system time variable and then the system sub rc value. Okay. So when I execute this, you see system language, then that is the system variable of the language E, then system time. Again, this is the system variable. Then you have system sub rc value that we have written as a hard code text. and then this is the actual size RC value. Okay, so this is a bit more convenient than in quotes. Okay, so that's how you kind of use it, and there are certain more functions that SAP has given. For example, reverse. So as the name suggests, string one, if you put inside reverse, you will get the reverse value of the particular variable. For example, if it was TEST, you will get as TSET, okay, as the reverse. Similarly, two upper, if you write two upper here, you will get the upper, two lower, you will get the lower case of the string. Then similarly, if there is something called as two upper, you will get the uppercase format of the string. For it, if we again execute this, you will see that this is the reverse one, then this is the lower case, and this is the uppercase. Okay, so this is what is there in short of pipe operator. And okay, so now one more thing is about concatenation. So a very convenient way of concatenating is possible now. That is through something called as concatenator operator with double ampersand. Okay, so if I comment this, you can see that you don't have to have any more keywords like concatenate or into the target variable, etc. Simply you can say the target variable is equal to, you can have your string, then you can simply concatenate by using the double ampersand along with it. So this will get concatenated with this will get concatenated with the variable string one, and so on. Okay, and for example, if at all you want again something to be added, you can do it like this. Okay, so you can concatenate your string as much as you want. So again, obviously concatenation, it's better that you only do it for character kind of thing, so that it is of the same data type. So we have done concatenation, we have done two upper, two lower, piping. So the other very convenient string processing or character processing is called as something called as alpha. So I guess everyone knows what is alpha. Alpha is nothing but a conversion, right? Conversion routine that is available in SAP. Okay, so in the current syntax, what happens is that, let's say you want to convert as an alpha input for this variable, you will use something called as conversion exit alpha input. Okay, similarly, you will have something called as conversion exit alpha output. So I hope everyone knows what is conversion exit, right? Anyone has any doubt? Okay, so in conversion exit, what happens is that you need sometimes the padding, like either you want to remove or add the padding. How do we do that? We do a call function, and then we have the input variable and the output variable, right? So that's how you kind of do it in the current way. However, SAP has made it a very convenient way where, for example, let's say there's something called as handling unit. Okay, so handling unit is something which is there in SAP for, let's say, delivery related things. So this is the particular data type. So when you see this data type, this is EXIDV handling unit, and this can be applied for anything. So I'm just giving one example. In EXIDV, when I go inside, you see that there is a conversion routine already available. So this only is applicable to those data elements, okay, or those data types which has a conversion routine associated with it. So when you see line number 589, okay, and when you compare, let's say, like for this, you can do directly for this particular variable LVHUIN. You can give the the data variable in which the value is there, and you can simply say alpha is equal to in or out, okay, depending upon your requirement. So what will happen is that if it is alpha in, okay, so for example, this is the variable, right? And there are 20 characters for that alpha. So it will add the leading zeros to make it 20. Okay. Similarly, if you want to make sure that you remove the padding so that you have the alpha output one, you just need to have alpha out. Okay. So let's just try to understand through the output. Okay. So what happened is that our initial variable was 1000. Okay. So when I did alpha equal to in, it gave me the padding with the external zeros, the leading zeros. Okay. Now, when I don't want the zeros, I did alpha equal to out. So when I did that, it removed the leading zeros. Similarly, what I did was there was something called as concatenation, right? So I simply concatenated both HUIN and HU out. So what it will do is it will just simply merge those particular variables and give me the output like this. Okay. So this was a very simple way of doing a alpha conversion or the conversion routine. So you can try it out with a bit of variable which has conversion routine attached to that variable. Sorry, the data element. Okay. If there is no data element, it doesn't work as such. I've seen with certain scenarios, if there's no data element, it will not work. Okay. And in a very basic, another example that SAP has given is something called as between. So again, this is something that is made based on the user scenario. What between does is that, if you see the statement 598, I've given the data type as XSD bool. So this is a data type. Okay. Data type is something called as a Boolean variable. Okay. So it is either true or false. So that means this particular variable either will have X or space. What I'm trying to tell the system is that variable that I have. So here this variable is the system variable for the day of the week. Okay. So day of the week can range from 0 to 6. So depending upon, let's say it is Saturday, Sunday, Monday, it will give a value to it. So what I'm telling the system is if the variable is between 0 to 6, then return true. Okay. So right now, we are maybe in Thursday right now. So it will be one of those values. Either it will be 1, 2, 3, 4 or something. So that means if it is true, it is within this range, then you return the value true to it. So true means X. Okay. So let's just kind of execute and see what happens. Okay. So the value is 4 because it is Thursday. So that's the reason it has returned the value X to it. Okay. So let's say if I change this to 3. Okay. I only want it to be true if it is between 0 and 3. So let's see. You see that the value was 4, right? Because it is Thursday. And since I've told only if it is 0 to 3 in between, you give me true value. Otherwise, you have to give me false. So this is what is a kind of a use case for between. However, obviously, as you can see, it is not that useful for us in our day-to-day operations. But yes, let us understand at least what is the use of this particular variable operator. Okay. So any questions so far in whatever we have learned?
Yes, Sumit.
Yeah.
Right here. So my doubt is whether for conversion and exit that we use all for statement we use now. So for that, whether we need to use curly braces or
yeah, so we need to use curly bracket. So I have also shared a note, right? Notepad
okay.
file. You can also try it out. What happens is you have a pipe operator. Okay. So this pipe operator is there. After that, since because this is a kind of a, we are giving a conversion. So it's better you always use the pipe operator. Then we have used curly bracket, because curly bracket is used to actually transfer the value of that variable, right? So that's the reason we use curly bracket and then the variable name. And within the variable, there are options like alpha. There are other options also. So right now we'll just concentrate on alpha.
Okay.
And you close the curly bracket and close the pipe operator.
Okay.
Okay. So if you remove the pipe operator, it won't work, because we are kind of first doing the values on this. So it's better that you have the pipe operator and make sure that there's no space in between, because if you give space, this will also treat as a character for this.
Okay.
So since this is of type character, it is okay. So when you kind of use and execute this, you will also have a space as well. Okay, you see you got a space.
Yeah.
So it's better that you are careful about this particular. So always, obviously, there's a space between the square bracket, the curly brackets, that is the syntax, but there should not be a space between the pipe operator and the bracket.
Okay.
Okay, so we'll move on to some.
Hello.
Yeah.
Yes, Sumit, one doubt. Regarding that conversion routine, will it not work if the domain does not have conversion routine mentioned in it, this alpha in and alpha out?
Yeah, so generally that is the documentation that is given for alpha. Okay. It uses the conversion routine that is available for that particular variable. Okay. So for example, this one has something called as alpha 20. Okay. So if there is a custom variable or data element that you have created, which does not have alpha in it. Okay. So 90% the compiler will try to do it on its own, and it might or it might not work, but it is something that there is no guarantee to it. Okay, so thumb rule is that you need to have at least a conversion routine attached to your data element. Okay, I've seen both the cases. Sometimes it works, sometimes it doesn't work. And depending upon your HANA version or the ECC version, it also depends. Okay, so it's always better that you understand that if at all the data element has that conversion routine, and also it should be alpha, right? Because we are using alpha here. It should not have something different. So you can do a try, with maybe a custom variable or a data element of a character 20 and remove alpha and try it out. It might work or it might not work. That is also another kind of a gray area with this new syntax for alpha.
So basically, if it's not working, we can still stick with the function module.
Yeah. This is not going off. This is still available.
Okay.
This is just a kind of a replacement for your convenience, right? For example, I would use this one because it's like an inline statement. Directly do it, and keep it. Here you need to have a call function, etc., and all that, right? So already you need to have 5 lines associated with it. Okay, so what we'll do is we'll come back to a bit advanced topic for the table expressions. So we'll understand something what is called as filter. Okay, so filter is something that is a bit I would say a non-conventional kind of thing, which we require a bit of understanding, in a detailed manner. So let me give you a scenario. What is a filter, right? So filter is nothing but, as the name suggests, you're trying to filter out certain data from an existing variable based upon your condition. Okay. So let's try to understand what are the steps associated with a filter. Okay. Now I'll give a scenario first, like what exactly where it is there. For example, you have an iTab. you have an iTab for, let's say, flight details. Okay. In flight details, obviously there is something called as destination country, okay, or a arrival country. So you can have, let's say, India, you can have Germany, you can have US, you can have, Japan, etc., etc. Okay. And what happens is, let's say you have around, let's say 1 million records. Okay, you have 1 million records, and you want to make sure that you only extract uh, data which is of having IN. Okay, only Indian records you want to get out of this particular internal table into another internal table called as Indian flights. Okay, so what you do is you basically do a loop. All right, you do a loop uh, at flight details, then you have something called as if country is equal to IN, then basically we'll do an append to this in flights table, right? Is this how you do it, or is there any other way that you do it? I guess this is the common way, right? Even if you don't remember, this is how we do it. We basically do a loop for the statement, and then we create a if condition. If that is satisfying that condition, we do a append to the target table, and then finally this will have, let's say, 500 rows with Indian flights. Is this correct? Is this how we do it in the current way, or is there any other way that we do? Anyone? Okay, so so you can see that it's a bit of time consuming process, and also there are multiple steps that we need to do, and it basically hampers the system performance also. Okay, because you need to do a loop and all those things. Now in filter, what we do it using the same scenario. The first step, what we do is that we create a this is what we create. We create a filter criteria. Okay. Okay, we create a filter criteria. So filter criteria means that we want to make sure that this is the field that we are going to kind of compare, right? Country from. So we do a begin of, and it can have multiple fields also. For example, country from, country to, etc., etc. But here we are going to create a very simple filter of one field, country from. And usually when you create it, you create a type for this, and then you create a table type. Now, since obviously we are creating it for a table, right? So when you create a table, you create it of hash table. So that is kind of a step that we do, okay? So that the filter can work. So we create a table type of type hash for the structure that we have created earlier in the earlier step. And then we give something called as unique key, okay? So obviously with a hash statement, you need to have a unique key with it, okay? So once we do this, then we are going to use it in the further steps for particular statements. So once we create the filter criteria, then let's say we have the base table. So base table is nothing but the flight details here, right? So here, let's say we'll put as base table is equal to flight details. So we identify which is the base table from which we need to get the value. So once we understand that, okay, this is the table from which we need to get the values into our sub table. So we identify the sub table which is required. So here the sub table would be LTSPFLI 1. Okay. For us, it will be IN flights. So we have understood what is the sub table. Now we also need to do something called as the filter table. So we have created the filter criteria. Okay, so filter criteria is nothing but a hash table type that we have created. Now this is the data, right? This is the base table in this program. This is the base table which has all the data, like it has German flights, Indian flights, etc., etc. What we do is now we create a filter. We've already created the filter criteria. We are going to create a filter table. Okay, so we create something called as filter table. Filter table is nothing but a temporary internal table with the criteria. Okay, so how do we do that? This we use the filter criteria table type, which is TT_FLT. Then what we do is we are telling the system that you just add the criteria in this internal table. So we have just added this row, okay, country from, in this particular filter. So ultimately this the filter table will not have anything. It will just have one row called country from is equal to DE. That's it. Okay. So that's kind of a step that we have done. First step was create a filter criteria. So here we know that we need something called as country from. Okay, that's the field. For that, we created the table type and we have kept it as a hash table. And as a base table, we know that this is the master table from which we want to filter the data. So we have identified that table. Then the sub table. The sub table is in which we have now going to transfer the filtered data. Like this will have the Indian flights. And then we have created the filter table. So this will only have that particular row called as country from is equal to DE. Okay. So in this, it will be country from equal to IN, right? That is what basically we want in our exercise. So once this is done, then we have the final statement where we do the filtering. How do we do that? This is the base, this is the sub table, right? So the sub table is IN flights is equal to, we give the keyword filter. Okay. We don't have to again give, like I told, because we have already given the table type and all that. SAP will try to understand what exactly this particular data type will be. You can give TT_FLT, not a problem. But it's better that you can also give F. That's the reason we have done all these steps. Okay. So we did do this filter hash. Then you can understand that this is our base table. Okay. Base table is the master table where we have all the flights. So we give flight details. Sorry. Flight details is the key, is the table here that we have identified. Okay. So we give the master table. Then we say that in the filter. So the keyword in, and then we have something called as the filter table, right? So filter table, let's say this is the FLT tab that we have created. So we'll say FLT_tab. Similarly here, this was the filter table that we have created, LT_FLT. Okay. So this is what we have also written. The master table in FLT, and then what we do is, then we also tell the system what should we compare the filter table data field with the field of the master table. Okay, so in the master table, this SPFLI. So when I go to SPFLI, there's something called as country FR. Okay, this is the field that I want to compare with the filter that I have set. So wherever this country_form data is equal to the data which is there in country FR, those values I want in my target table. So this is the field which is there in the master table, country FR, is equal to the field which is there in my filter table. Okay. So basically, this is what will be the syntax. The syntax is, this is your target table in which you want the final data to reside. Then you have equal sign, you have the keyword filter, you can give the data type. Then this is the master table or the base table that we've identified in step 2. Then you can say that, this is the keyword called in, that we are telling that whatever is there in the filter table, you compare with the values and only return me those values which match this condition. So finally, what happens is, in one single step, this is one single step, you will have all the values returned to in flight. So this will only have flights where country from is equal to IN. Okay, it from the base table. Any questions for this? You want me to repeat again?
Yes, Sunil.
Okay, you want me to repeat, right?
Yeah.
Okay. So, so did we understand this particular the scenario? What we are trying to achieve first, like we are trying to filter only in Indian flights to our target table. We have understood scenario, right? First, what we want to achieve.
Yeah. Scenario is clear.
So scenario is clear, and the current way that we do is also clear. Like we do a loop and then we kind of do it. Okay, so this is a bit performance issues also when it comes to, let's say there are millions of records. Okay, so what we do is first we create a filter criteria. Okay, we are telling the system that we want to create a criteria to which we need to apply the filter. Okay, so the filter is how we kind of create a filter is we create a filter where we kind of first create a structure to that. Okay, the structure will have the criteria. This country from is there. Okay, the country from, we have created the structure and we have created a table type for it. The reason that we have created a table type is that an internal table will be used for using as a filter. Okay, so the first step is to create a filter criteria. Filter criteria. Create a table type for that, and then you also create the filter table. So this is called as a filter table. So you create a filter table with the criteria that you have created, and in that you specify that you want the country from is equal to DE. So in our scenario, it will be IN. Okay, you just press IN to this. So what we achieved right now is that we have created a filter criteria. We have identified this is the master table in which all the values are there. This particular table, right? This table, this which will have Indian, German, US, Japan, all those flights. So we have understood that this is the details in which everything is there, and this is the target field in table in which we only want Indian flights. So we've understood those as the second and the third step. After that, we create something called as the filter table, which is nothing but this, which we understood. LT underscore flight. So this flight table, what will happen is that it will be used in the actual syntax. So the syntax is LT underscore SPFLI2, which is your final target table, right? So in this, the target table is nothing but IN flights. Okay. So IN flights, Indian flights is equal to filter. Then this is your master table in which all the data is there. Indian, Japanese, German, all the flights are there. And you say that that is the condition that you have put, 436 line. Whatever is there in my filter table, but you compare, right? This is on a table, this is also a table. So you compare wherever this is getting matched. For example, country from is there in your table and country for is there in the base table. So you tell that, compare with German. So the value is German. For example, I also want okay. So you can have multiple criteria within the internal table. Okay. So what will happen is, can people go on mute? Yeah. So what happens is then now you have two conditions in your filter. I want both German and Indian flights, right? So when you do that, automatically it will compare German and Indian flights with the base table. Okay, so finally you will have a table that, a target table where you will have both Indian and German flights. So, I mean, what you can do is that you can just try it out, as a sample. You'll understand it once you do all these steps one by one. Okay. Was the concept clear or you are still having doubts?
I have one doubt here. This country from, can we like make it depend on the user input?
This country from?
Yeah, like when we are creating a filter table, we
So
have
you
country
can
from as,
define,
yeah.
you can define the data type, okay, data element, but this thing you can give a variable here. Okay. For example, you can
Okay.
give p underscore user input, right? You have a parameter that the user has given. So you can write this.
I was like, if I can maintain a select options here, like country from in s underscore user, can I do that here? And like,
Yeah. So for example, I've given you parameter here, right?
yeah,
Directly
yeah, yeah.
parameter to parameter you can do. So this is, since a equal sign, you need to first extract it as a single input. Okay. And then you need to write it one by one. Okay. Because in a select option, you will have sign, you have equal sign and all that, right? That was not required. You need to only have the actual value with it. Did you get my point?
Yeah, yeah, yeah.
Okay. So, just try this out. Like I told, this is something which is a bit different. COM, okay. Similarly, there is also a negation to this. For example, you only want those flights which are non-Indian. Okay, that means you want to remove this particular country itself from your the database table, or the sorry, not database, the internal table. So you can have a negation. So in this scenario, what will happen is this particular target table will have all the values except Germany and India. Okay, so that's how you kind of do it. Okay. So once you understand in, the other one is just the opposite, that you only want those values which are not. So that's how the keyword is, except in this particular criteria. So all the flights will be there except Germany and India. Okay. Okay. Then so this anyway we saw earlier, the value statement can be used to get the particular data, right? And then also use space if at all this particular criteria is not matched. So this is anyways available as before. Okay, so now is it okay that we continue till 9:15? Anyone has any other meetings?
You can continue, Sean.
Okay. So we have another variable called as, another operator called as reduce operator. Okay. So I'll again give a scenario for reduce operator. So let's say you have an internal table, let's say like this, okay? So these are the values in your internal table. Okay, this is the values. So for example, this is your first row, second row, third row. So you have certain things in internal table like this. Okay. So there is a scenario where you want to add up all these value. So I think the most common thing again is basically you loop itab and then you kind of do a sum. Sum is equal to sum plus this work area, right? This is how kind of you do it. Is this the only way or any other way that is there? I think this is the only common way that we do, right? If at all you want to sum everything together, you do a loop and then sum is equal to sum plus one, etc. And then you can, finally you can write sum. Okay. Now, again, as you can see, there's again a loop that is required and all that. So in SAP, there is something they have also tried to make it a bit similar to what is there in C++. Okay. So in C++, what happens is that, you can also do like this now, where you can have a for loop, j is equal to 1 while, so you can forget about this for now. This is just because I wanted to create an internal table with 10 lines of integer value. Okay, so this is something that I'll take it up later. If at all you are able to understand, it is similar to what is there in C++. You have a for j is equal to 1. That means you have initialized the counter to 1 while j is less than or equal to 10. And then you are trying to say j is equal to j plus 1. Okay, so what will happen is this particular table will have values like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so if you see, there are 10 rows and the sum will be around 55. Okay, so this is how you kind of create a using for loop also, which is possible. Now what happens is that, like I told, if you want to sum this table, you need to do a loop itab into a work area, and then you do sum is equal to sum plus 1. So this is all okay if it is some maybe 10 line items. So what if there are millions of records? Okay, again you need to loop and do all this thing. We can use something called as reduce. Okay, so what we do is, again, this is an operator, you have a left hand side to it. So in the left hand side, you have created an inline data variable called as sum. Then you use the keyword called as reduce. Okay, so you use the keyword or the operator name reduce. Then you have the data type. So we know the data type is I. Okay, then you initialize the counter, like how many times you want to use that particular iteration. So first you initialize that counter x is equal to 0. Then we tell something that for work area in itab 1. Okay. So what I mean is that you already have an internal table that you have created, right? Internal table 1, 2, 3, 4, 5, 6, 7, and 9, 10. So in order to loop, you need a work area. So this work area is a temporary one. You don't have to declare anything outside this. You can directly declare like this, within line number 456. So you don't have to do like data work area type line of itab 1. You don't have to do that. Okay. The syntax is directly use the initialization x is equal to 0, and then you use for work area in itab 1, and this is the counter, like x is equal to x plus wa. This is something as sum is equal to sum plus wa. Okay, so this is the initialization of the sum value, like you set it to 0. then you also make sure that sum is equal to sum plus 1, and you're telling that you want it from the entire internal table. Okay, so finally what will happen is it will sum all these values in one shot. So if you see, the value is 55, and let's try to write the value of this. Yeah, so reducing a table to a variable, and it comes with 55. Okay, I'll just put an underline as well. I know this is a bit new and a bit over the top, so I want to take some time and ask, is both the concept okay about filter and reduce? Like, what is the use case, and why do we use it, and then how do we use it?
But regarding this reduce,
Yeah,
is it restricted to integer types only, or can we use it for currencies and all as well?
you can you can use that. If I'm not wrong, I think I've tried it for character to concatenate as well. Okay, so you can try that out once with character. For example, reduce, you can have string. Okay, and then x is equal to x, something like this. Okay, and maybe x, I'll say like this. So let okay, so I'll check and let you know about this. Maybe it is not possible, but definitely I think I've done it for I. I'll have to remember how I've done it for, let's say, a character.
Yes, Sumit, I have a doubt here. So this internal table is having only one column, right?
Yeah.
So if multiple columns are there and I need to sum one column, so whether that is possible?
Yeah, you can do like work area hyphen that particular thing. Okay. So you can give a work area hyphen this. So you can use that. So how you do it in a loop, right? So you do a loop at work area, and then you have something called as work area hyphen field one, correct?
Yeah.
Same thing, you can use it here as well. Like which field you want to submit.
Fine. Thank you so much.
Yeah. Okay, so again, this is there in that text file that I've given. So you can try it out. Obviously, what we are trying to understand is the concept. There can be variations, and like you've given me a question, I'll come back and let you know if we can do it for a character or some kind of other variables. Okay. Any other concept related issues, whatever we have learned today? Yeah.
Yeah, in the reduce part, if the internal table is having of multiple fields and multiple addition needs to be done, we just create another variable under that.
For example, you're saying that there is another column, let's say 3, like this. There are 2 columns in this table, correct?
Yeah, and these 2 columns, I need this sum. So how can we?
So you can have another this, like for example, and then you can have this is field 1, and then this is field 2, right?
Yeah. Oh.
Or if you want that You know,
Can we just return that field to under the same?
so you're saying like this, is it? Plus WA field 2.
Yeah.
Yeah, I think this is possible, you know, because this is ultimately you're looping this internal table. So this work area will be accessible. You can have both the fields. So you're saying this is getting added together, correct? 1 plus 3 in the first
Yeah.
iteration. Then, yeah. So this is possible. Okay, you can try it out. And if it is not working, let me know. Okay. So this is the syntax if you want to use it. For any or that matter, let's say you want to add a constant, so you can add like 5. Okay, always. Obviously this will give an error because the fields are not there. So for your simulation, what we'll do is we'll give a constant. Okay. So you see this, we added 4 10 times, right? So 55 plus 4, 40, we'll get 95. So similarly, you know, when you're trying to loop, you can take the second column as well for your addition. Okay. 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 So there are 2 more concepts in the table expression. Before I move on, so that concept was okay. Reduce and filter.
Yes.
Okay. So there is one more concept. Maybe I'll take that now itself, you know, so that you can understand it together. There's something called as for and let operator. Okay. So what happens is that there is a scenario that you have itab 1, then you have itab 2. Okay. So in itab 1, you have the source data. Okay. And for some reason, you want to populate the itab 2 with this data. Okay. Target data. So what usually you do is that you do itab 2 is equal to itab 1, right? You can directly do this. So automatically this data will get transferred in this particular variable, correct? Is that how you do it, right? You kind of do a transfer of data, but for some reason you need to make some manipulation before you transfer the data into itab 2. So for that, what you do a loop at itab 1 into work area 1. Okay, then append work area 1 into itab 2. If both the structures are same, right? You do like this. If at all you want to do some changes, for example, work area field 1 is equal to work area field 1 plus some 10. Okay. So if you want to do some manipulation, you want to do a loop and then append it and do the end loop, correct? So again, there are certain number of steps that we have to follow. For loop, what you can do is that you can directly use the source table and then use a for loop to manipulate the data and just put it in the target table. Okay. So now again, I'll just give a very brief summary. We'll repeat in the next session as well. So this is the target table. Okay, itab index 3. We use the value operator. We use the table type or the structure. So again, the value statement is same. we open the bracket and use something called as for. Okay, for statement. Now after that, we create a temporary work area. Okay, so this work area is declared at 465. Okay, so this 465 at line item, you have this work area that is created inline. Okay, you have not created somewhere else. So this is something that is going to be used within this particular block of code itself. So once you do this, then in statement and then itab underscore index. So that is your target, source table, the table that we have seen in itab 1. Okay, and what we are trying to tell, okay, forget about this right now. We are just telling that this is the target field, the field of itab index 3. Okay, this is the target field of itab index 3. We are telling that the first column of this particular table you transfer as it is. The second column you transfer as it is. But the third column, I want to multiply it by a constant which I have declared in this particular field. Okay. So again, I'll take it up in the next session also. I'm just giving a very brief introduction. What is a for loop? Okay. So let's just forget about this. Okay, so what is happening here is, if you forget about what syntax it is there, so let's say this has 3 columns. Okay, this index 3 has 3 columns: field 1, field 2, field 3. So in conventional ABAP, what we do is we do a loop, and then for the third column we say field 1 is equal to, field 3 is equal to field 3 into 10, and then we append it as it is. So here SAP is giving you an option to manipulate data for each column in this way. For example, the first column you don't want to do anything. The second column you don't want to do it anything. You transfer the data as it is. But for the third column, you want certain conditions. Okay, so you can say field 3 is equal to the field 3 into 10. Okay, so what will happen is this particular index table. So let's say if itab 1 was having, let's say 1, 2, 3, this is the value. itab 2 will have 1, 2, and 30. Okay, so this will become the target variable, so target table data. So how we do that? We use something called as for loop. This is called as a for and let something. So let is because if at all we want to define any constant that we want to use it. So if you want to use it in any field, we need to have a in variable. So let's forget about let and all that. Let's try to just understand the very basic. How do we use a for loop? A for loop is used to transfer data from a source table to a target table using certain keywords like value, etc. And then we have an open bracket and close bracket. So you have field 1 is equal to something. So this is the field of target table. This is the field of source table. Okay. Any questions on this? Was this very over the top, or did we understand somewhat? Was this clear?
Yes, sir.
Okay. So I think in the interest of time and the complexity, I will not go further. My suggestion is that you try this out if you have your system with you where this is possible, what this for loop does. Okay. So again, I'm just repeating, maybe I'll take 2 minutes. For loop is required to make sure that you transfer data from one table to another table. But in the process, if you need to manipulate any fields or any columns of the first table. For example, I wanted to make sure that the third column is basically some multiplication factor that we want to do. So we do in conventional ABAP is we do a loop and then we kind of do a into sign, right? Like this. But here directly what we can do, we do a loop value statement, the for statement, and do a into 10. You can even do a variable also. For example, if there was a variable that the user has input, you can do anything. It's up to us. Okay. If it was a character, you can also do something called as like this also. Okay. So you can do anything at that particular line. Right now, obviously, this is an integer type. So I'll use the integer operators. Okay, so with this, I'll end the session for now. What all is there is that, I'll just come to a summary sheet. In the new syntax, there was something called as, inline data declaration. Then there was constructor expressions. Then there was internal table operations. Then there was string operations. Then after that we have this filter, reduce, for loop, and there will be something called as base in the next session. So more or less, whatever I've covered here is something that you will be using 95% of the times in your actual day-to-day work. Okay, and beyond this is something that SAP will keep on coming up with new things, but it will mostly be similar to what is there here. Okay, it will be like minor variations of what is possible. Okay, so in the next session, what we will be covering is we'll covering something called as base operator and also the SQL queries. So with this, we will be able to finish the new syntax chapters. Okay, then after that, we'll have CDS and then we'll have AMD3. Okay, so we'll have maybe 2 to 3 sessions more. So this will get